Hello everyone, I'm Bill Braden of Team MarTech. Welcome to Cudahy Hall, the computer science building here at Marquette University. Here we are at the Systems Lab where we have been working on our minimum viable product for the SDN Innovation Challenge. Let me introduce you to the rest of the team. Jake Scheitel, our web and front-end developer, Rob Grease and Paul Schmidt, our back-end developers, and Sam Oslin, our team videographer and application tester. Before we jump into our demo, take a quick look at our initial pitch. The problem today is that there isn't a good way to simulate networks.
If it doesn't work at all, we don't know what happened.
Current networks are difficult to configure.
SDN lets you change that.
Our goal is to develop a platform that allows students to test and debug networking applications.
Adding latency, corrupting the packets, fragmenting the packets so they come in different order.
Generate traffic, make it feel like we're actually working on the internet.
Emulate environments that behave realistically.
Create problems artificially and test them that way.
Test new topology ideas, maybe try different optimization.
You wouldn't have to worry about damaging the equipment or taking down an entire network.
It would be a lot faster, a lot easier, and a lot more elegant.
After several months of research and development, we're excited to present our minimum viable product, ENE, the Educational Network Emulator.
We developed ENE as a plugin to OpenDaylight. Following the web development strategies used by existing OpenDaylight plugins, we were able to design a user-friendly front end that deploys configurations to an SDN controller. Let's take a look. On the left, users can create configurations for traffic manipulation. For this demo, we'll test the basic Unix ping command. However, the same configurations can be used to test any network application. We start by adding a traffic manipulator and assigning it an ID. We'll call this one drop 50. A manipulator is composed of a series of rules that map a source and destination host to a series of actions. These actions will only be applied to traffic moving between these two hosts. We specify the IP address and port of the source and destination hosts, then we can add actions. Actions represent the way we want to manipulate the traffic that matches our rule. At the moment, we can drop, delay, duplicate, or corrupt packets. For this manipulator, let's drop, say, 50% of packets. Now this is a bit extreme. We don't really see this in a production environment, but it helps to demonstrate what our application can do. At this point, we can save the action, the rule, and the manipulator, and we're good to go. We can add additional actions and rules if we want. This sends a request to the web controller to save this configuration for later use. The manipulator hasn't actually started yet. At this point, we're ready to try out pinging. As you can see, the ping is behaving normally. The sequence numbers increment by 1. Back in ENE, we can begin to test by selecting our manipulator in the control pane and clicking Start. This sends a request to the web controller to start applying rules in this manipulator to traffic passing through the SDN controller. Now we can see that some of the ping packets are being dropped. The sequence numbers are skipping. Our application works. We've added a custom statistics pane that displays information about a manipulation while it's running. As we refresh, we can see that 50% of the packets are being dropped. Let's test ping against a manipulation that duplicates each packet 5 times. It's interesting to see how these applications respond to this behavior. Let's corrupt a couple bytes in our ping packets. Ping doesn't like that. ENE manipulations can also be used to test applications against flood attacks. Let's change our duplicate multiplier from 5 to 20,000. A primitive application like ping is not built to handle this kind of traffic, and as you can see, it's skipping quite a bit. Let's see how ENE runs in the back end.
After the user presses start, our application listens to packets sent across the network and determines whether they should be manipulated. The user-specified traffic rules are used to make this determination. This is the block diagram of our application. Once a packet has been determined to match a traffic rule, ENE will manipulate the packet according to the traffic action. During the manipulation of the packet, the stats module will be updated. Let's take a look at how ENE traffic manipulations will affect a file download. We start by downloading a 100 megabyte file. As you can see, it's going to take us about a minute. Now we jump into ENE and start a traffic manipulation that drops packets. Now we can see that the download time spikes up to around 30 minutes. Because TCP is reliable, we see that we will be able to finish the download eventually. It'll just take longer.
If you really wanted to see how, suppose, your new latest and greatest streaming service actually worked, you can then use our application and see the real effects of a packet drop. Okay, so we have it streaming right now, no manipulations. As you can see, things are looking pretty fine. If you've noticed, it's a familiar video. And so we're going to now introduce the streaming. How about, say, 5% of a packet drop? So let me set that up here. Okay, 5%. Now, as you can see, the video is starting to lose some serious quality, even with just a 5% drop. Now, suppose we up the ante a little bit. Let's try 50%. And here we go, add in 50%. And pretty amazing. And then if you stop it, just wait a little bit here. There it goes. All right, back to normal. So as you can see here, this is a very visual way to see our application in action, but it really shows the potential that it has.
We set out to create a network emulator for the SDN Innovation Challenge.
With ENE, we can actually see it. We can actually see those emergent internet conditions that you don't regularly see on an ideal LAN.
We feel that our minimum viable product demonstrates the power of SDN technology and provides a testing tool not only for students, but for network administrators and application developers. We'd like to thank Extreme Networks for this opportunity and look forward to sharing our project with the SDN community.